File system management in system. This presentation dives into the core of file system management with operating system concerning of efficient data storage and retrieval while exploring the interactive layers that orchestrate how data is organized, accessed, and protected on storage devices. This is from understanding fundamental concepts like directories and other metadata to examine advanced techniques for optimizing disk space and ensuring disk data integrity. This presentation aims to provide a comprehensive overview of the file system management. We will cover the architecture and underpinning various under organizational techniques, organizational strategies, and essential operations, and the crucial aspects of the data management. Now we will dive into the file system management from now onwards. File system architecture, layered architecture. There are two types of file system architecture: layered architecture and virtual file system (VFS). File system employ a layered architecture from modularity and abstraction. This includes user interface, file management, and I/O control. User interface provides the means for users and application for interaction and file system. File management handles the organization and access metadata management. I/O control manages the physical reading and writing of the data storage. The virtual file system, the VFS. The virtual file system provides an abstract layer and that allows application to access different files and systems in uniform manager, and abstraction hides the special details of each file system that manage the implementation of consistency. It ensures that the data is consistent and can interact with the files and the directories of the system. Set as an example of Linux VFX architecture. We will take the example of Linux here, where which file system is related to the virtual file system. Now moving on to the next slide, file organization. There are basically the organization of file can be divided into three parts: contiguous allocation, linked allocation, indexed allocation. In contiguous allocation, each file occupies a contiguous set of block on the disk. This is simple but inflexible. Now the linked allocation avoids fragmentation by allowing the files to be stored in non-contiguous block linked together using pointer. Index allocation uses an index block to store the pointers and enabling the files and enabling efficient random access. Simple implement. So the what are the advantages of contiguous allocation? Simple implementation. It is very easy to implement. Now fast sequential access. It is very easy to access sequentially in this contiguous allocation. Inflexible, but the disadvantage is prone for external fragmentation. It is difficult. We face very difficulties in external fragmentation in contiguous memory allocation. Now the linked allocation have the following advantages: avoid fragmentation, slow random access, and the main overhead of this is requires space for pointers. Now indexed allocation, efficient random access. It is very efficient because it has a very random access. Overhead requires space for index blocks. Complexity, more complex implementation. Now directory structure. What are the directory structure of basically the single level basically the directories? Now there are basically four types of structures: single level directory, two level directory, tree structured directory, and acyclic graph directory. So basically these directories are these are the directory structures. So what is single level directory? So the single level directory is nothing that a single level directory is simple, built, limited as files reside in the same directory. So basically the file here reside in the same directory is a simple directory. Now a two level directory. What is two level directory? A two level directory provides user specific directories of offering better organization. Basically it provides separate directories to store the data or the or anything or the content to provide better organization. Tree structured directory. A tree structured directory offers a hierarchical organization enabling a complex file system. So basically in tree structured directory. It is very easy for searching, and it provides a hierarchical tree like this in this pattern, so from which we can easily access the files, or we can easily search the file. Acyclic graph directory shows the shared file and directories without cycles, enhancing flexibility. It's basically increases the flexibility of storing the data. Now we will move on to the next slide. File system operations, creating files. Basically, what are the operations in file system? So basically there are 4 operations: creating files, reading files, writing files, and deleting files. These are the main basic operations in file system. As you can see on the screen, creating files means allocates disk space and create a new entry in the directory structure. Basically it creates a new folder or creates a new file in the directory which occupies some spaces in the memory. Reading files retrieves data from a file and transfer it into memory. Basically it reads the file, what is the content inside the file. It's known as reading file. Writing file basically stores the data into a file, updating the file's content. In writing the data means updating the data, manipulating the data. Deleting file, removing a file entry from the directory and deallocates the space. Basically we create the in creating the file we allocate some memory spaces. It's just opposes it as creating files. In deleting file, the allocated memory deallocates from the storage, the main memory. So this is all about file or system operations. Now metadata management. What is metadata management? So basically how the metadata can be managed. So basically there are 3 key attributes: file attribute, consistency, and storing metadata. So what are file attributes? Metadata includes file attributes such as name, size, type, and timestamps, which describe the file properties and characteristics. So basically a file attributes nothing but the name of the file, what is the type of the file, what is the size of that file, what are the permissions that are required for that file. So these are the basic file attributes of a metadata management. Storing metadata. How to store metadata? Metadata is typically stored in inodes. Basically metadata can be only stored in the inodes. Basically the index nodes or the file allocation tables, FAT, providing a structured way to organize file information. Consistency. Metadata consistency mechanism ensures the file system are automatic and durable, preventing data loss and consumption. So basically consistency ensures that the data loss is not prevented, and the data loss cannot be corrupted, and the data loss is flexible. Not the data loss is flexible, but the data is flexible. Now moving on to the next slide. Disk space management. How to manage disk space? So basically to manage disk space there are basically some of the techniques that are used. The we have 3 basic techniques to manage the disk space. The first management technique is free space management. So what is free space management? Technique for tracking and allocating free disk space such as bit vector, linked list, and grouping, and essential for effective storage utilization. Disk quotes and allocation limits enforces storage and uses policies, preventing individual users for grouping and consuming essential disk space. Fragmentation means dividing the spaces. Fragmentation and defragmentation techniques aims to reduce the impact of file fragmentation, improving disk performance and access limit. So basically this is all about disk management. File system protection. So basically how to protect a file. In this slide we will get to know about how to protect the file. Access control lists, and data integrity. Access control mechanisms such as owner group and world permission regulates access to the file and directories, preventing unauthorized access and modification. Access control lists, ACL, provides free-grained control over the file and directory permission, allowing administrator to specify right for individual users of the group. Data integrity. Encrypting and data integrity techniques such as checksum and cryptographic hashes protect the file and tampering and ensures authenticity. Case study. So basically there are some case study related to that. FAT32, NetFuzz, NATFAS, and x64, APFS. APFS is basically Apple's modern file system, and FAT32 is simply simple and widely supported but limited for file size capabilities. Sorry. NTFS is advanced feature like generalizing and security. ext4 is robust and scale file system for Linux. Future trends. So what are the future trends in file system? Log structured file system, object based storage, and persistent memory file. These are the three future trends we can see in file system in upcoming world. Log structured file. What is log structured file system? Optimized for write performance by writing all the data sequentially to a log. So basically it writes all the data sequentially to a log. Scalability and cloud integrity with storage managed as object. Persistent memory file system, low latency and high bandwidth for emerging persistent memory technologies. So basically these are the basic future trends of file system. And this is all about for today's video. Hope you liked the video of this OS topic, file system.